process of how we are going to be given an input and how we are going to be get an output. So that is nothing but what are the operations we are going to be perform on data. Okay. So how we are going to be deal with data set and how we are going to be get useful patterns or useful statistics on the data. So either maybe we may consider that, for example, we have when a weather data set or we have a word count program or any other similar things are there, then how we are going to be produce an output, a proper output for the given data. So given data set, how we are going to be doing. So so anyone having the idea of what we discuss in Hadoop input output? Anyone? What we discussed in the Hadoop input output? Anyone? Okay, we saw about how writable and write comparable, how we are going to be do with so Java comparator. I will remember these and other things we were discussed. So even we, once again we can refresh our things. Hadoop comes with a set of primitive for data input and output. Some of these are techniques that are more general than Hadoop, such as data integrity, compression, but deserves a special consideration when dealing with multi-terabyte data set. So we know that we have a large number of data, so multi-terabytes of data. So that is maybe a zettabyte or petabytes of data we can do. So other the Hadoop to our API. So that is the tools are we can have some APIs. So from the building blocks for developing a distributed system, such as a serialized framework on the disk data structure. So how we are going to make useful patterns in order to get in a proper statistics. So whenever the user is going to be respond with the system, how he is going to be get all those things, how he is going to be get the information clearly from the given data set. So what are the basic commodity of the data and how we are. Hello. Hello.
Yes, sir.
Okay, thank you. So use of this, how the data we are going to be make a useful patterns. So how it is going to be write, read and write in order to update the data in the data set. So that we are going to be see how it is going to be writable, how we are going to be compare. So where we the task tracker and job tracker we have task tracker and job tracker, how it is going to be. Have a crucial role to update the data in a proper manner, how we are going to be seeing everything. Okay. So here we are going to be talk about main concept about data integrity. So what is the concept of integrity? So what is word meaning of integrity? In the cryptography network security also we are talking about integrity, data integrity, authentication, and security mechanisms are there. So what is the meaning of this word integrity? It's a combines. So where we are going to be perform some message digest operations on the data. So we are going to use an integrity. So users of Hadoop rightly expect that no data will be lost or corrupted during the storage or process. So we have a petabytes of data. So if the data is available in huge, so the user has to think that how much data is going to be stored. That the data should be processed. Every data should be processed. For example, we have lots of number of rows and columns are there in data set. So if the data set's number of columns are there, so the user is going to be performed in a particular row or particular column on the data set. So if in that particular one data set, the user must have to maintain and he has to process completely without any interpretation. So in order to process, so the integrity must be considered for each and every data. So that is, however, since every input output operation on this network carries with its small changes of introducing errors into the data, a reading or writing. When the volume of data moving through the system are enlarged as big one. So other reason capable of handling the chance of data corruption occurring is high. So we have doing the operation with the then the high availability of process also there. So in order to avoid this one, so we need to know about how come we can perform the integrity. How can we have to get the all the data without any corruption. So that is the usual way of detecting corrupted data is by computing a checksum. So for example, if your friend is chatting with you, for example, simply your friends or chatting with you, that for example, send hi, how are you? Where are you? If ask some message, for example, you receive a message, hi, how are you? You didn't receive where are you? So how come you know that the sender is to think that okay, didn't reply to the message, or he didn't see that message, or he didn't get the message. He can think that in a different way whether the data is sent or not. Yes, sir. So even if the receiver may receive or may not receive, may for example he don't know anything about this. For example, if he thinks that he received only, for example, he received only how are hi how are you? This is the message. Hi again that and how are you? Fine. He says. So the sender is think that he doesn't want to say about where are you? Right now where he is. Yes, sir. But the receiver didn't receive the question where are you? So we need to recheck whether the data is sent properly. So how we can check it? So simply if the two are a proper connection, everything is there, then immediately if you don't have acknowledgement, immediately next we are going to be asked where are you? Next question, same question we are going to be repeating. Yes, sir. So previous data is either he received or don't receive. So that is a simple meaning of how we are going to be checking. So that's why we need to identify that whether the continuity of data is available or not. Continuity of data, how we do. So for example, simply we know the poker game. So how the game is going to be. So one display is going to be the code to the other one. So simply it is going to be repeat. So how it will be? So when we are using this one, so the person who is detecting the code to the other one, the game is going to be started. The same way, the data one we have the information about the next data and the previous one. I think we have the IP header, RTCP header, UDP header, every data header should contain the information about the so the receiver or sender immediately knows that something is happening with the data. The data was collected. Anything is easily identified. So or else we can simply say, for example, we can come to the for example. So I am going to send my total data. For example, if I am going to say I, for example, I h, what is the number of h, what is the number of I. So everything I am going to be calculated, I am going to be simply say that for example, it is a 90, value of 90 I will show. So this is the total integrity of the total of the data. If I am sending the data, that data to the receiver, then we need to the receiver is received with the data and it has to with that. So that's why we talk about message authentication. So in the order of day, the receiver has to calculate again the integrity. That is the message is going to be calculated and it is going to be compared with the sender message the both are saying, then we can say that the data is properly received. Something we have a link with one data to another data. So that linking is there properly linked or not by the computing of checksum is going to be and the first thing we have the system again whatever you are expected to establish the unreliable the data is demanded to be correct if the newly generated checksum does not exactly match with the original. Does not match with the original. So the technique does not often fix the data. Merely it is important to use error detection. So error correction and error detection is so error correction and error detection. So we were find out something error from the data. So and this reason for now using a low end hardware in particular to be sure that to use ECC memory. So electronically uh, corrected that is error detection code. So that we are going to be seeing. So now that is the possible that is the checksum that is correct, no, not the data, but it is very unlikely since the checksum must be smaller than the data. So the data which we are going to be sending for the checksum is smaller than the original data. So that is always it is true. Again, the commonly error detecting code is a cyclic redundant statement. Everyone is a cyclic redundant check. With the computing of 32-bit integer checksum for input of any such. So very well. So data integrity, how we are going to be performing in the HDFS. So we simply we ultimately talk about what is integrity. Now we are going to be talk about how the data integrity in HDFS. So HDFS transparently checksum all data written to it and by default verifies the checksum when reading it. So a sequence checksum is created for every input output dot checksum. So it is a package name. So byte of data. The default size is 512 bytes, and since the CRP32 checksum is 4 bytes of data. So if you remember header tag, so IP header or TCP header, there is a pointer checksum. What is the size of checksum? 4 bytes. No? So same thing 4 bytes. The storage is overhead less than by that we can never compare the checksum size is very less compared to the processing size. Okay. So the data nodes are responsible for verifying data. Yes, we know that main node is the responsibility for managing and maintaining network data. And the data nodes are responsible for verifying the data, receiving other data. That is, we can simply say that the physical data. We are going to be talking about the physical data. Data by receiving before storing the data and its checks. So this applies to the data. Applies to the data that they receive from clients and other data nodes during the replication. What happens? We are going to do the replication. A client writing data send it to the pipeline of data nodes as explained. So next three third chapter we said how the data is sent to pipeline one after one after. And the last data node in the pipeline verifies the checksum. If it detects an error, the client receives the checksum. That is exception. So no exception handling how we are going to do. So a subclass of input exception, which should be handled in an application specific manner. So by retraining the operation, retrying or something we are going to be getting back. So if the proper data is not received, when we have some application to detect and we are going to be asking same thing. For example, when the client read the data from data nodes, so we know that the physical data is available at the data. The client is reading the data from data and verifies the checksum as well as the data is reading the time itself. We do how much data we are getting from the data. So what is the checksum of that particular data? So comparing them once it is stored in the data, each data node keeps the persistence log of checksum. So persistence logs how much data is how much data we were sending and how much data still it is there. So how much data is that is the log is number. So at the details of whenever we is asked about the data, the client is asked from the data nodes, everything comes data is asked. So whenever the client is asked, is going to be maintained. So that is going to be taken up in the. So when the clients read the data from the maintenance, they check some answer and comparing. So here again, see. So each data node keeps the persistent log of checksum and verification. It means that last time each log was verified. So generally, whenever we are going to be login, so last login was this one, last login. Even if we Google sheet anything, if we are going to be updated or something, so what is going to be shown? So the last login is this, last login is this, something is shown like that. The latest one is edited, the who is modified the data is shown. So when the client successfully verifies the log, it tells the data nodes which updates the clients. So keeping statistics such these values valuables in detection of bad data. So maybe how many times useful data is available. So which is the bad record? Simply we are uninterested data. We are going to be taking interested data from the data set. So we can see that which data is not useful, which data is maybe a bad record. So how you can find the value? For example, the data is generated from any source. So in my lab is for example. So for example, we can talk about the lab. For example, if I ask something, if you come to lab, I'm asking enter everyone enter in the lab. So I may have some fields in the lab. I need to confirm that. So how I'm going to check the attendance. Please take me. That's a problem. Remember, internet everything is clear. Then you have to be staying for example maximum 3%. So I need to consider the hours you are in the lab and PVA or something. So so the use of data is completely always get the complete data. Then only I can consider the same. Whenever we have the data is going to be considered in a storage, definitely we have some logs for that. So when these logs are not properly built, these things are not properly. So such type of data we are going to be cognizant. So such persons who are geometry maybe name or data missing, somewhere missing something, time is missing something. So he is unable to enter something is problem. Then I'm going to be removed from the pool. So that is. So aside of block verification, when the client reads each data block scanner. So in a background thread that periodically verifies all the blocks stored on the data nodes. This is to guard against the corruption due to the bit row. So in the physical storage media, see the data block node scanner. So that will be saying let a pre-partition page about the data node blocks. So details how the scanner works. So since the HDFS stores the replication of blocks, so we know that how the replication is there, how the blocks are going to be same blocks should not be in the one rack. So we're going to be keep the blocks in different racks. So I remember or not, I don't know. Rack management, rack algorithm also is some people, but so store the replicas of blocks and it can be corrected by copying replicas by producing a new so unconnected replica. So by this way, the works as if the client detects an error by reading a block. So we again here we have something interesting. So if any bad reports are there, so why we want to make a replicate? For example, if something is going to be updated, so something is going to be error in the data. So the previous data was get replicated. So what is going to be happening? Even something data is missed in the replication. So we need to finalize the data. Once the data is written off, so finalize the and the replication is going to be happen. Then only if anything is happening with the original data, we are going to be getting the data. If any clients detects an error reading the data was trying to read from the data before main node before it checks some exception. So whenever it is possible, if something is wrong with the data, then it is going to be send it as a checksum. The main node marks the block replicas as correct. So if something is checksum, exception is passed, then we know that something is correct. So if there is no clients are so I'm trying to copy this replicas so the data is so its replication factor is expected. Once this has happened, the corrected replica is before using the open network, the same effect is possible from shall by using the ignore CNC, that is some commands ignore CSC cycle predetermination. So how we are going to option we can get the equivalent copy to local one. So the feature is used to having a correct file that you want to inspect. You can decide what to do on it. For example, you might want to see that whether it is solved before it is going to be deleted. So how going to be stored? How we are going to be checking it? If the checksum is not going to be matched with the data, or if something is a problem with the data, how we are going to be passing instructions to the data, how we are going to be how we are going to be finally we are going to be it is something corrected. So if it is how the local file system is going to be. So after now we are going to be talking about the file system. So how we even if we are the Hadoop is going to be installed in 3 ways local the local file system how it is Hadoop local file system performs a client side checksum. This means that we want to write a file called file name. The file name client transparently creates a hidden file name.csv. So in the same directory containing the checksums for the need to check out the file like HDFS. The checksum size is controlled by something that is the input output by checksum cover, which defaults to 5 bytes. The checksum is stored within checksums are verified and if any error is detected, the local file system throws the checksum exception. Checksum in Java implemented native code. It's typically adding a few percent overhead time to time read and write a file. For most applications, this is an applicable price to pay for data integrity. It is, however, the possible to disable checksum. The typically when we supports checksums native. This is accomplished by the row of local file system. In layers of local file system to be globally an application. It's supposed to be the remap the implementation of file by setting the properties. So how the Hadoop is going to be installed in the local file system. That time we are going to be setting the properties. Implementation. The value. So this accomplished by the raw local system where the place so that is the file implementation to the family. So where we have the ORG data, Apache data, raw local files. So instead of local files, we are going to be with this file system we are going to image. So alternatively, you can directly create a local system which may be useful if you want to disable the checksum verification for only some of it. For example, we know that how we are going to do the configuration by installing the configuration COM and configuration for FSS, new raw file system, and some simple code to how to configure. So under one is the checksum file system, we are going to do. these files are easy to arrange to others. Checks. The file system is just wrapped around the file system. The general items are as follows. So how the file system is going to be used. So the underlying file system is called the raw file system. So raw means original we make a raw. So maybe it is retrieved by using a get raw file system. Checksum file. The checksum file system has a few more useful methods for working with checksum, such as get checksum file and getting the path of the checksum file. So these checks for using for the checksum is to be on the same device. Administration periodically checks these files and take action. So then we have how we are going to be comparison. File comparison brings two major benefits. It reduces the space needed to store the files and it speed up the data transfers across the network. R to R from this. When dealing with a large volume of data, both of these savings can be significant. So it pays to careful control about the comparison in files. So how we are going to keep the files in the stores in a local system in a network system. That is we can simply call a local file system or distributed file system. How it is going to be dealing with this. So there are many different compressions format tools and algorithms. So each with the different characteristics. So here we have see that the compression format maybe we have DF late. So tool nothing something like that. Algorithm what we have. The file extension and split. So something we remember that zip file whenever we are going to be download the configurations, it may be a file or something application, the data how we are going to be extracted down zip files. So that is so zip to zip 3. So everything we have some file extensions. So by seeing this extension, we know what type of file we are using. We can here we have all the compression algorithm exhibits space, time, space and time. The faster comparison and decompression speeds usually come at the expense of smaller space savings. The tools listed in the table, something for the previous table, typically gives some control over the trade-off at comparison time by 9 different options. This one means optimize the speed with the following commands creates the compare compress file dot gz. So gz is what is the extension? Gz is the gz. So that tool we are going to use. So gz file -1 file. So the different tools which we are going to be used. The different tool which we have very different comparison characteristics. gz space time and so that the zip2 compresses the more efficiently than reads, but slow. So bzip2 decompresses the stream faster than bzip, but it's still slower than bzip. On the other hand, the both optimizes for the speed and alone the order to magnitude with faster. But the compiler the less effective. So snappy is the logic significantly faster than decompression. So the splittable, so that it indicates whether the comparison format supports the splitting, that is, whether you can so the different tools we have different comparison characters, which is a general purpose command. So the different tool may have the different comparison character, which is a general purpose command, and 6 is the middle and space time. So compress more efficiently. So by efficiently, how we are going to be doing the compression. So we every installation of file, so we are going to be extract. So somewhere we are going to be downloaded. From the downloaded file to we are going to be copy that file into the root file. So how we are going to be copy and how we are going to be extract with the command. And why we are talking about here the command. So in Unix operating system, everything we are going to be operated through the command summary. I think we know sample views, I hope what is the CD and or remove or RM, how we are going to do it. So how everything is operated through terminal or something command summary is going to be so it will be the comparison format that it is whenever you want to see to the stream and the same for comparison format are especially suitable for so how the codes are there and how we are
Simulation of bank
so compression and decompression stream with compression. So compression code that allows you to easily compress, decompress data. To compress the data being written to an output stream, use the create output stream of methods to create compression output stream, to which we write our compressed data to have written in compressed from the underlying stream. So how we are going to be do the compress? So we are dealing with a large amount of data. So how the data is going to be compressed and decompressed again. So whenever the client is needed, we need to process with the decompressor. So that both we need to talk about it. Okay. So compression output and the compression input streams are similar to. So we have here some two packages are mentioned. So except both the former format which are able to reset underlying. So compressing So both are important to applications to compress the section. So the data streams are separated, blocks, files. So here we have ports are available. And let me, I want to know that, so let me start the class. And I have